Hey guys, welcome back to YT Classroom. I hope you all are doing well. So today we are looking at IGCSE Physics 0625 Paper 2 Variant 1 from May June 2024. If you are new to this channel, do not forget to like, share and subscribe to this channel for more upcoming videos, especially for the 2024 series May June papers. Alright, let's start on the paper. So basically, we're going to look through every question. I'm going to give you a detailed explanation on every question, which will help you. And best of luck to all of those who are attempting the October-November 2024 exams. I hope this video will help you. Let's move on. So now we are question number 1. There are 40 questions in this paper. Question number 1 says, in which row are quantities correctly categorized into scalar quantities and vector quantities? Now the point is scalar quantities are quantities which only have a magnitude, which is like a numerical value, whereas vector quantities have a numerical value as well as a direction. So first, let's look at option A, which says the scalar quantities in A, mass and energy. Now mass and energy both are scalar quantities indeed because they only have magnitude, not have supposed of directions. So we can say that for this is correct. But also could look at the other side, weight, which is a force. So that is a vector quantity indeed because a force is always a vector quantity, and acceleration also vector quantity because it involves velocity. So we can say that these both are correct, but I'll also go to the other options as well. Now here in scalar quantities, gravitational field strength. Any type of field strength, including gravitational and electric field strength, are not scalar quantities. So this option can be dismissed. All the time is a scalar quantity. Force and electric field strength, again they both are vector quantities. But again, one option, the scalar quantity is not correct, so indeed we can't choose option B. Option C, V for example, it says speed and momentum. So speed is a scalar quantity, the vector is basically velocity. So speed is correct, but momentum no, because momentum involves velocity. So this momentum is wrong, and therefore option C would also be wrong. If you check the other side, it says distance and force. Distance is a scalar quantity. If you want for a vector, that is displacement. So we can skip distance as distance is wrong. Force is again a vector quantity. And option D says distance and energy. Now distance and energy both are scalar. So this option might sound correct to you because they're both. But velocity and temperature is not a vector quantity. Temperature is a scalar quantity. Therefore option D is wrong. And option A is the correct one. Second says that which name is given to the quantity of matter in an object. The quantity of matter is referred to as mass. Density is basically, how concentrated the matter is in the volume, the mass of a volume. Volume is how much space it occupies, and weight is the gravitational force acting on the object due to its mass. A body is moved from place X to place Y where the gravitational field strength is different. What happens to its mass and its weight due to the move? Now, whenever you move from any place, one place to different place, the mass remains the same. For example, you move from planet A to planet B, the mass would remain the same. Only thing that changes would be the weight because the gravitational field strength is different in different planets. And since W is equals to mg, so obviously the value of W will change, the value of mg changes. M will stay the same. So we have to select option C, which is that M stays the same whereas W changes. Alright. So the first option is A, the second is B, and the third is C. Moving on, it says that the mass of an object is 2.5 kg and the volume of the object is 480. What is density? So density, which is represented by rho, is equals to mass divided by the volume. Now, here you can see in the answer that the units are all given in grams per centimeter cube, so you have to make sure they're working in the same units. So 2.5 kg is basically 2500 grams into 1000, and volume is given in centimeter cube, so just divide 2500 divided by 480. 2500 divided by 480, that would give you 5.2083 that gives you 5.2. So answer is 4B. Alright, I hope this is clear. Moving on, it says that four objects each have two forces acting on them. Which object is in equilibrium? Equilibrium basically means that there's no resultant force and there's no resultant moment as well. If you see option A, basically the both forces acting in opposite directions and have equal magnitude, therefore they cancel out each other. Therefore the correct answer is option A. Option B wouldn't be because this force is acting this side, so it will almost produce a turning effect. The resultant moment is not zero. And if you see C, then the object will be pushed towards this direction, and for D it will be pushed towards this direction. So all of them are wrong, only A is correct. Now a ball of mass m falls vertically and hits a hard surface. Its speed on hitting the surface is v1. It rebounds vertically upwards with speed v2. What is the change in momentum of the ball? Now first thing to know is that what is the formula for momentum? Momentum is mass into velocity. Now whenever I want to change in momentum, the change in momentum, delta P is equals to m into v2 minus v1. That is your final velocity, or maybe I could say this way, v minus u, that is the final velocity minus the initial velocity. Now remember, this is the velocity and this is not the speed. So we are saying that when the ball was falling down, it has a v1, and when moving up, it has v2. So normally you would get the thought that basically in the formula that m into v minus u, v represents final and u represents initial. So we can say m, the final is basically v2. Now remember that these are velocities, so we have to take a direction. For example, if you're considering moving down as positive, that means moving up would be negative. Alright, you guys have to be careful for that. Then what I would do is, the final is basically, for example, I would say, okay, let's say the final is negative, so negative v2, that is negative v2, and we're subtracting negative v1. So because we could take, or in other words, even if you could do this, that is an alternative for this would be, if you take basically going down as negative, so going up would be positive. So down, when I take m, and the final velocity is basically v2. So when it's going v2, it's positive, this is v2, and when it's falling down, it's negative, that is v1. So when I subtract this, basically, remember that when it's falling down, it's negative, right? So v1, negative of v1, because I'm subtracting and then it's already a negative number. So the final answer will be m into v2 plus v1, which is correctly given as option C. I'm going to repeat myself here if you guys haven't understood. The formula is momentum is equals to change mass into velocity. Change in momentum is equals to mass into v minus u. V minus u represents, v represents the final velocity, u represents the initial velocity. So the final velocity we are taking, if you take final as upwards, because it is moving up as it says here, and if you take that value as positive, that means when you're coming down, if you take the value as negative, because of velocity, that involves the direction. So this would be v2 positive, and if you take v1, it will be negative. And this is in opposite directions, so v2 minus v1 is negative, so I put negative as well. So when you do minus minus, it will be plus, and therefore the correct answer would be that. Next up, it says that a stone is dropped from a tall tower and falls a distance of 50 meters to the ground. The stone has a mass of 3 kg. At what speed does it hit the ground? Now here, in these types of questions, these are very repeating questions. So the formula to remember is that the energy that it had at the top, which is due to gravitational potential energy, will be same as the kinetic energy, because energy, law of conservation of energy, it cannot be lost, it cannot be created or destroyed. GPE is equals to kinetic energy. So what is the energy, like gravitational potential energy it has at top, which is calculated using mgh? It'll be the same as kinetic energy, which is half mv square when it touches the ground. Now what is the m of the ball? It's 3, that is the mass. G is 9.8 and h is 50 meters. When you multiply that, basically 3 into 9.8 into 50, it should be equal to half mv square. Half, the value of mass remains same, the value of v square is something that we have to find. And when you multiply 3 into 9.8 to 50, you get 1470. If you want to find v square, you would just divide basically half into 3 on the other side. You would take it to the other side, they're being multiplied here, so you take it, divide half into 3. Half into 3 is basically 1.5. When I divide my answer by 1.5, I get 980. So v squared is basically 980. This would give me v squared. V squared is 980. If you take the root of 980, that gives you 31.3. So v is basically 31.3. Do we have option as 31.3? Closest is 31, so you take that option, 7B. Now it says a coal-fired power station generates electricity. Coal is burned and the energy released is used to boil water. The steam from the water makes the generator move and this produces electricity. Which row gives the name of the energy stored in the coal and the energy stored in the moving generator? So basically, this is a theoretical question, and words in coal always you have chemical energy. Geothermal is from the rocks which are under the ground, but coal has chemical energy. And it says that the steam of the water makes the generator move. So when the generator is moving, then only able to generate electricity, hence kinetic energy. Hydroelectric would involve some form of water being used to basically turn the turbine, which turns the generator. But here we're using the steam to turn the generator, so it would be kinetic and chemical. So 8B. Moving on. A man puts some ice onto a glass of water on a warm day. After a short time, he notices that ice disappears and the water droplets appearing on the outside of the glass. Which two changes of state are taking place? This is a repeated question. If you've done the past papers, you would know that basically the reason for the ice disappearing is melting, and the reason for the water droplets appearing is because the outside surface of the glass is cold. So whatever vapors are there in the air, they come on and they condense onto that cold surface. So there's condensation taking place for the vapors which are outside, and there's melting of the ice. So it would be 9b. Moving on, it says a gas of piston 200 centimeter cubes is trapped inside a container by a piston. The piston is pushed to the right and the volume of the gas decreases to 100 centimeter cubed. So it says that you have 200 centimeter cubed of gas which is trapped inside this container by a piston. Now we move this piston towards the right and the volume of the gas decreases to 100 centimeter cubed. However, the temperature remains constant. Which row states the effect that this has on the kinetic energy of the gas particles and the force per unit area exerted by the particles connected by the surface? So it says that when you decrease the volume while the temperature remains constant, what happens to kinetic energy and what happens to force per unit area? Now, when you consider kinetic energy is half mv square. So we know that half m hasn't changed. And because the temperature remains the same, that means the velocity would not change. This is an important point to remember. The velocity would only change when the temperature changes. So the kinetic energy would stay the same. So I can cancel out option A and B. The force per unit area. Now, because they're particles in a smaller area, so they would collide more frequently with the walls. So they would exert, basically, it would lead to more pressure being exerted in the walls. And force per unit area is basically pressure. So that would double. So our correct answer would be C. Moving on, it says that which row shows the relationship between the pressure and the volume of a fixed mass at gas at constant temperature. Now, this is basically thing that pressure and volume are inversely proportional. So if you decrease the volume, then the particles collide more frequently with the walls and the pressure would increase. Whereas if you increase the volume, the molecules collide less frequently and the pressure would decrease. So for the graph of basically these types of graphs which are inversely proportional, the only option is D. As you can see, when the pressure goes as the pressure increases, the volume is decreasing, and as the volume increases, the pressure is decreasing. So the correct answer is D. Now, question number 12. During evaporation of liquid, the most energetic particles escape. The temperature of the remaining liquid decreases. Which row identifies where these particles escape from and describe the temperature change? Now, in evaporation, always they escape from the surface of the liquid because this is where the particles are the most energetic particles. So they surface the liquid and the temperature of the remaining liquid decreases. Why does it decrease? Because if the liquid is losing the particles with the most energy, so the remaining liquid, it has the particles, they have less energy, therefore the temperature decreases. So 12C. Wet clothes are put on a line to allow the water in the clothes to evaporate. Which type of weather would cause the water to evaporate the most quickly? Now, for evaporation, conditions are that the higher the temperature, the faster water would evaporate. And if you have wind, what would happen is that the evaporated particles would be carried away quickly before they can return back to the surface. So indeed, the answer would be 13D, with a hot day with wind. Now, it says that question number 14 has been removed. Question number 15, a solar water heater is designed to absorb energy from the sunlight. Which surface texture and color would be the best for the solar water heater? When you want to absorb energy the best, it would be dull black. Shiny would still reflect it compared to dull, so dull is a better option. White is not a good absorber or a good reflector, and shiny white is the worst absorber. So indeed, you would go with dull black, which is 15A. Moving on, question number 16. It says that which type of waves is correct? Waves do not transfer either energy or matter. No, they do transfer energy. Waves transfer both energy or matter. No, they transfer energy without transferring matter. Waves transfer energy without transferring matter. So this would be correct. Waves don't transfer matter, they transfer energy. So option would be 16C. Alright. Now it says that the angle of incidence of a ray of light incident on a plane will gradually increase. To the nearest degree, what is the maximum possible angle between the incident and the reflected rays? Now for this question, I would show you guys in the diagram. So if you consider this as a surface like a mirror and this as your normal line, so I could have a very large angle of reflection. Basically, for example, I'm trying to make it as close as 179 degrees. This would go here. Then suppose that this angle is basically 89. The whole is 90 and this is 89 or 89.5, let's say. And this is also 89.5. So when you round them up, it would be 90 and 90, and 90 and 90 adds up to 180 degrees. This is the angle of incidence and this is the angle of reflection. I hope this is clear. Now it says that which two conditions are required for the light to be totally internally reflected. The conditions are that the incident ray should be in the more dense material or more optically dense material compared to the materials traveling to, and the angle of incidence should be greater than the critical angle. So incident should be in the more dense medium, that means A and B are wrong. C, it can be one of C and D, and the angle of incidence should be greater than the critical angle. So 17 would be D. Alright, I mean 17 is already D, 18 is also D. Alright, now let's move on to question number 19. The diagram shows a ray of light passing from air into a transparent substance. What is the refractive index of the transparent substance? The refractive index is basically n, which is equal to sine I divided by sine r. Alright, so when you do this, sine I is the incident angle, sine of 40 over sine r, which is the reflected sine of 30. When you put this in a calculator, sine of 40 divided by sine of 30, that gives you 1.29. So you can take 19b. 20. The diagram shows a ray of light in optical fiber, which correctly describes the condition for the maximum transmission of light by the optical fiber. Now, indeed, first thing should be that it should be as slow as possible, because if it's talking about two things in all of the options: the slow, that means like the speed, and the critical angle. You would want your critical angle to be basically as small as possible. Now hear me out on why do you want this, because the critical angle defines the angle of incidence that you need for total interreflection. When you have a small critical angle, there'll be more number of rays that would be able to totally internally reflect. So when you have more rays that totally reflecting, that means your signal will be carried more accurately. So critical angle should be as small as possible. So that means A is wrong and C is wrong, because they say critical angle should be as large as possible. Then the glass also must slow the light as much as possible. Why? Because if it's traveling fast, then it almost has basically a very high critical angle. If you want a low critical angle refers to, it also refers, if you do n, which is, or if you do n, which is basically the speed in air divided by the speed in basically the material, and n is equals to 1 over sine c. So sine c is equals to 1 over n. So if we have a basically if your light is traveling down slow, then your critical angle must also be slow. So indeed, you should go with option D. The glass must slow the light as much as possible to make the critical angle for the fiber as small as possible. I hope you understand the second reason, that critical angle is small, so more is will be total interreflect. And why should the light itself be slow? Basically, then it will be able to totally internally reflect. If the light is traveling fast, then it can be difficult to totally internally reflect. And the most property, if you have a material with a high critical angle, then the light would be indeed traveling slowly. Alright, now let's move on to the next question. Which region of the electromagnetic spectrum is used for detecting fake banknotes? That is basically ultraviolet, and this is a part of the application of the electromagnetic spectrum bands. So these, you have the notes, they have markings which glow in a UV lighting. Then it says that there's a sound wave given like a 330 meters per second is the speed. The distance between compression, center of compression to center of rarefaction is 2.5 centimeter. What is the frequency? If you use that V is equals to F lambda, so what you want to find is frequency. Frequency equals to V over lambda. What is V? Is given 330 meters per second. Meters per second is the best unit. But now here you see that the distance 2.5 is between the center of compression and rarefaction. But whenever we want the wavelength, it should be center of compression to center of compression, or center of rarefaction to center of rarefaction. So this is basically half the wavelength. So 2.5, so we'll double that, it will give us 5. And since it's in centimeters, I would take divided by 100 to give it in meters. Now simply put this in your calculator, 330 divided by 5, alright, sorry for that. That gives me basically 6,600 hertz, so option should be C, 22C. Moving on, which waves are used in the medical scanning of soft tissue? That's basically ultrasound waves, as you know, ultrasounds, so ultrasound waves. Which will describe suitable materials for use in temporary magnet and permanent magnet. Now, in temporary magnet, you should use a material that would basically soft magnetic material, so just soft iron. But for a permanent magnet, you want to retain its magnetism, so you should use steel, because that's a hard magnetic material. 24p. 25 is a magnetic field is represented in the diagram by magnetic field lines. At which point is the magnetic field strongest? Now, in these types of questions, the diagrams, the magnetic field will be strongest where the lines are close together. And as you can see at point A, the lines are very close together, so it would be indeed be point A, 25A. Moving on to question number 26. It says a student determines the resistance of a resistor R. She uses a circuit involving a voltmeter and an ammeter. What circuit does she use? Now let's look at circuit A. At circuit A, she has connected the voltmeter in parallel, which is wrong. Now voltmeter in series. Voltmeter should always be in parallel. That means we disqualify this option. Now in option B, she's connected the voltmeter correctly in series, but the ammeter should be voltmeter is parallel, which is correct, but ammeter is in series. So that's wrong. Ammeter should be in series, basically in series, not just parallel. Always remember voltmeter in parallel, ammeter in series. Here the voltmeter is in series but the ammeter is parallel, so this is also wrong. Here the ammeter is in series, which is correct, and the voltmeter is in parallel, which is also correct. Now it says that a diode and a resistor are connected across a variable DC supply. Terminal X is initially positive and at a maximum value. The potential difference across XY is adjusted so that it changes as shown by the graph. Boudreau shows how the current in the circuit from X to Y varies during the same time interval. Boudreau shows us how the current in the graph. So basically, they're telling us that there are two inputs, X and Y, and what is connected between them? There's a potential difference between X and Y, and it's a DC supply, shows across a variable DC supply. X is initially positive and it has a maximum value, and then potential changes shown by the graph. So the potential difference is basically going from this direction. At this point, basically at this point and pointing here, it's going to change direction. So it goes from Y to X rather. Which graph shows how the current in the circuit varies from if you current an X from Y during the same time. Now remember, when the current is basically like X to Y, it would not flow because it's not in the direction of the diode. The diode says that current can only flow upwards. So only when it changes direction, then only there'd be a current. So that is only being said by D. Again, you have to see the direction of the diode, and if the diode is pointing in the upward direction, that means that current can only flow when it's going like this, which is negative direction. So it would be indeed D. The question is 27 is basically D. Moving on, it says when a conductor is in a complete circuit, when a conductor in a complete circuit cuts across a magnetic field, a current is induced in the conductor. Which statement about the induced current is correct? Okay, so the induced current in the same direction as the motion of the conductor? No. For this, you can use your left hand rule, and if you see the direction of your induced current, which is represented by your middle finger, and your direction of motion, which is represented by upward, that's the force. A represents basically the direction of magnetic field, and your middle finger represents the direction of your current, and upwards your thumb represents the force. So as you can see, the three are perpendicular to each other, not in the same direction, so A is wrong. The induced current is in the opposite direction? No, they're perpendicular. You have to use the term perpendicular. The direction of the induced current is in the same direction of magnetic field? Again, no. It's in the perpendicular direction. The direction of the induced current opposes the change that is causing it. Now this is correct. This is a statement that you learn throughout your syllabus, that whatever is induced current, it will always oppose the change that is causing it. And this is basically a part of Lenz's law as well. The direction shows a solenoid carrying an electric current. Boudreau compares the strength of the magnetic field to the solenoid at points Y and Z with the strength of the magnetic point at X. At X and Y, it will basically be the same. You know why? Because inside such a coil, the magnetic field is basically uniform. You have these straight lines, which will be equally spaced, so it's uniform. So at Y, it's equal to X. So C and D are wrong. But at Z, because now it's further away, so the magnetic field strength decreases as you move away, so it would be less. So 29 would be basically A. Moving on to question number 30. Now here it says a conducting wire is placed between the poles of a magnet. When an electric current in the wires is in the direction below, then the wires on the force of the wires acts out of the page. So for this, you would basically again use a left hand rule. Your index finger or pointing finger points from north to south, that is basically towards your right, and your middle finger is representation of current, which is currently, let's say, towards you at this point, and the force is upwards, which is out of the page. Now it says that when the direction of the current is towards the top of the page. Towards the top of the page means that basically you would need to point your index finger, no, not your index, your middle finger in the other direction, because currently it's at the moving out of the page, basically moving bottom of the page. So move your index finger. Currently, the hand direction is basically pointing the current in the direction of out bottom of the page. So on the top of the page, you would basically move it on the other side, and let the magnetic field be in the same direction, that is towards the right. So you would see that the force is now into the page. It's completely opposite. So 1 is correct. Now again, return back to the same position of your hand. That is your index finger towards the right, your middle finger towards you, and the force should be upwards. Now it says when the current is towards the bottom of the page. All right, now you take the current as the bottom of the page. Now currently current is towards the left, and what does that represent? I mean, current is towards you. That is basically towards the bottom of the page, and the magnetic field is reversed. When the magnetic field is reversed, you keep your middle finger the same, but the magnetic field, so your hand will move to opposite direction. Your index finger now points towards the left. You would see that your thumb is now downwards. So again, that too is also correct. It says when the current is alternating, the wire vibrates in and out of the page quickly. Yes, because it's alternating, and the direction of the current is changing quickly, so it alternates. So 1, 2, and 3. For this, try to use your hand, and then only you can get it. Okay, I'm just gonna read it, do it once more if you guys haven't understood from the previous explanation. First of all, you use your left hand. Your index finger is from the north to south, that is towards your right. Your middle finger points towards you, that is the current, and the force is upwards right now because the force is acting out of the page. Remember, upwards, when your thumb is up, it's out of the page. Now, first statement: when the current is towards the top of the page. Currently, your middle finger is towards the bottom of the page. So towards the top of the page means you have to tilt it to all the way to the other side. And magnetic field is remaining the same, that is towards the right. So your force, as you can see, your thumb is downwards. So 1 is correct. Now return your hand to the same position when the current is now towards the bottom of the page. That is, it is going in the same direction. The magnetic field is reversed. Magnetic field is reversed means that your index finger points in the other direction. Again, you see your force is downwards, and 3 I already explained, so that is correct. Which type of electric current in the primary coil and the secondary coil or the setup transformer? In the primary coil, you have an alternating current, and in the secondary coil also you have an alternating current. So 31 would be A. A scientist fires alpha particles at a very thin sheet of gold and detects the particles that pass through. Which statement about the results of the scattering experiment is correct? So in that, when you reflect it, when you basically shine fires alpha particles very thin sheet of gold, you would see that alpha particles, let's go to all the options, they're attracted to the nucleus in the metal sheet. Because alpha particles are positive, the nucleus also positive, so they're actually deflected from it. Half of the mass of the atom is considered in the nucleus. It's not half, it's almost like above, it's much more than half, so not B. Most of the alpha particles are deflected. It's not most now, because the atom is basically empty space. The nucleus is very small, so most of them would pass undeflected. Only a small number of, option D says only a small number of particles are deflected. Yes, because nucleus is very small, so it cannot do for all. But when these are deflected, it deflected at very large angles because the nucleus is indeed very dense. So 32D. Now 33, the notation represents the nucleus of a gold atom. 197, which is the number of neutrons plus protons, or the atomic mass. 79 is the atomic number of protons. The relative charge of proton is 1. What is the relative charge? The relative charge is basically, since for 1 proton it's plus 1, you have 79 protons, so plus 79. Next up, an isotope of hydrogen has a nuclear notation 2,1H. How many neutrons are in the nucleus of isotope, and what is the relative charge of the nucleus? An isotope has nuclear notation 1, 2, 1, so it prevents 1 proton and then 1 neutron. So the number of neutrons is 1, and the relative charge, since you only have 1 proton, then you have 1 relative charge, so 1, 1. Basically 2 is telling you the number of protons plus neutrons, and 1 is only protons, so that means neutrons must be only 1. So that means you have 1 neutron, 1 proton, and the relative charge will be 1 because only 1 proton. A radioactive source is placed in a detector. The radiation arriving at the detector from the source is measured for 10 minutes with different materials placed between the source and detector. Okay, when you didn't put anything, this is the radiation. When you put a sheet of paper, it's 5629, so it's almost very close. It's a bit higher indeed, so not a difference. But when you put a thick sheet of aluminum through it, beta would be stopped, alpha and beta. So then, basically, when you put a sheet of paper, alpha would have been stopped if there was alpha, but alpha, there was no alpha, therefore there's no significant decrease. When you put thin sheet of aluminum, that means beta would have been stopped. There's a significant decrease, so beta is obviously there. And when you put lead, again, there would further a large decrease. That means you have beta and lead. Beta and gamma. The aluminium stops the beta particles, which is a significant decrease, and the lead stops the gamma. Then it says the reading on the detector placed in a radioactive source is 536 counts per minute. The radioactive count rate is 44 counts per second. The background. So the reading on the meter is 536, and the background is 44. The half-life is 34. What is the reading after 68? Now in these types of questions, the 536 involves the background. So involving for calculations, you deduct it. 536 minus 44. 536 minus 44 gives you 492. So 492 is for the material itself. Now in 68 hours, it would basically go through two half-lives because for 34, it's just one half-life. So with the 492 value, I'm going to divide it by 2. That would give me 246. That is after one half-life. I would further divide it by 2. That gives me 123. So 123. Now do not put this answer because you still have the background radiation to consider. So when I do 123 plus 44, that gives me 167. The working for this, if you want to show, like if you want to understand, 536, I've written the first a subtraction. Then 492 divided by 2 is basically, just give me 1 minute. 492 divided by 2 is 246. 246 divided by 2 is basically 123, and 123 we're going to add the background back, so 44, 167. So 36 would be D, 167. A planet in the solar system is at a point in orbit when it closest to the sun. Which row is it the correct? Now, when you're closest to the sun, you have the maximum amount of kinetic energy and the minimum gravitational potential energy, because gravitational potential depends on the height, and when you're closest to the sun, your height between, like the distance between you and the sun is very less. So orbital speed would be maximum, but the gravitational potential energy would be minimum. So 37 would be B. 38, the main process that powers the sun is basically the nuclear fusion of hydrogen to form helium. Alright, 38C, this is a third question. Now to the speed, a galaxy is the 3.010 to the power from the Earth. At what speed is the galaxy moving away from the Earth? Now for this, you have to use the Hubble's constant. That is, Hubble's constant is equal to the speed at which the galaxy is moving away from the Earth over the distance from the Earth. So in order to find the speed, we have to multiply the Hubble's constant value, which is 2.010 to the power negative 18, into the distance, which is basically 3.0 into 10 to the power of 20. 10 to the power of 20. When you multiply this, you get 600. When you basically get 600, so that means the closest value here is 660, so you would take this value. Moving on, we basically multiply the value of Hubble's constant, which you can see is given in the exam, in your syllabus in the textbook, with the value of the distance to get the speed. Now it shows an astronomer observe a distant galaxy. The table shows how the distance and the speed of recession are determined. Which row is correct? Now if you want to determine the distance, you see the brightness of the supernova in the galaxy, not the brightness of the galaxy. This is not a valid method, brightness of the galaxy. The option can be A and B. And the speed of recession, we don't consider the brightness of galaxy again, so this option can't be true. Brightness of galaxy is not a valid method, so only option correct is A, which is brightness of supernova in the galaxy, and the speed of recession, the change in the wavelength of a starlight from the galaxy. That is basically, it would be redshifted because it's moving further away. Alright, so this is the end of the paper. For the last question, again I would repeat that is change in the wavelength is just for the redshift that you get, that is basically the part of this topic. Brightness of supernova galaxy, this is basically not in depth in the syllabus, but often comes for MCQs. There's a last part in the textbook which you can read for this, and for the speed of recession, it's being redshifted because it's moving away, just like in the Doppler's effect. So I hope this video helped you guys, and I hope all of the questions are clear. And if you have any doubts, I was able to help to them. And again, if you have any more doubts in these questions or any other questions, you can email me, you can comment down below. Moreover, if these videos are really helpful, I would appreciate that if you guys could purchase a super thanks, and that would be really helpful to me. Alright, see you then. If you have any past paper suggestions or for any topic that you would like to make a video on, please do comment down below, and I'll try my best to make a video on it as soon as possible. Enjoy your studies and preparation for past papers, especially for the October-November series or even the May-June 2025 series. Alright, peace out.